Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Elisha. Today, my group is going to present about our hydrology group project based on the district Kelantan. We are from Group 4, Section 8. These are our group members: Putra Malik Khalid, Adli Nurliana, Nur Elisha, Nurul Yasmin, and Siti Hazirah.
So firstly, I will present about the introduction. So for the introduction, hydrograph help us understand how water move and how to manage a flood risk, especially in area with heavy rainfall and seasonal monsoon. This project focus on the Kelantan River, which is the catchment area in Gua Musang and Kuala Kerai, which that an area highly prone to flooding due to heavy rainfall, steep rains and limited drainage by Samsudin ETAL 2014. Using a Google Earth Pro, a rainfall and a water level data we obtained from the Department of Irrigation and Drainage. The study involved mapping the catchment, analysis the rainfall and runoff pattern by plotting the hydrograph and hydrograph, and calculate the peak flow using the rational method and meaning equation. The goal is to understand how the catchment respond during the high rainfall event due to assess the flood risk. This real-world case study help apply hydrological tools and engineering knowledge to improve flood management and planning water resources in Malaysia. So next, I will pass to the next presenter.
For the objective of our project, the first one is to analyze the hydrological behavior of the Kelantan River catchment area between Gua Musang and Kuala Kerai using real rainfall and water level data. The second objective is to evaluate the relationship between rainfall and runoff through the development of hydrograph and hydrographs. The third objective of our project is to enhance students' understanding of flood risk and mitigation planning. The fourth objective is to utilize digital tools such as Google Earth Pro and Public Info Banjir for spatial data collection and flood monitoring analysis. The fifth objective is to estimate the peak discharge values during high-intensity rainfall events using rational methods and Manning's equation. The last one is to assess the influence of topography and land use on flood occurrence and stream flow response.
So now I'm going to be explaining about the methodology that we used in this project. So for our data collection, there are two websites that we use. The first one is Public Info Banjir. So this website shows real-time rainfall data system from nearly 200 hydrological stations all across Malaysia. And from here, we access rainfall and also water level data from chosen state, which is Kelantan. And this website also displays current flood information alongside flooded areas. So the station that we chose in Kelantan are Station Gua Musang, Dabong, Kuala Kerai, and our main river flow is Kelantan River. And the station that is nearest with Kelantan River is Station Kuala Kerai that will be used in hydrograph and also peak flow calculation. So from this website, we obtain the hydrograph and also hydrograph of our chosen stations, which are Station Kuala Kerai and also Kelantan River. So the next website that we use is Google Earth Pro. So this website shows 3D application of the globe, including satellite imagery, 3D terrains, building views, street views, and also historical imagery. So from this website, we managed to gather necessary information and also analyze geographical data of our stations. And from here, also we determine our catchment boundary area, overland path length, and also overland surface slope. Not only that, we also determine the residential, roads, highways in a catchment boundary area to determine our runoff coefficient value. Next, there are two graphs that were obtained from Public Info Banjir website in order to analyze the data that we collected. The first one is hydrograph. The data inside the hydrograph will be used to calculate the station's discharge value and also will be used in our separation method to calculate the UH ordinance. The second figure is hydrograph of Sungai Kelantan. Lastly, for the peak flow calculation, there are two methods that we use. The first one is rational method. According to David B. Thompson, 2006, this is a technique to estimate the design discharge from a small watershed, and the formula goes by Q equals to CIA over 360, where C is runoff coefficient, I is average rainfall intensity, A is catchment area, and Q is the peak flow value. So the second method that we used in peak flow calculation is the Manning's equation. According to Jerkley et al. 2018, this is a technique that is regularly used to estimate discharge, energy dissipation, and also other physical phenomena. And the formula goes by Q equals to 1 over N AR to the power of 2 over 3 SO to the power of 1 over 2, which the Q is the discharge of water, A is the area of cross-section, SO is slope of waterway, and N is Manning's roughness coefficient.
Hai, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera. I am Putra Malik Khalid bin Abdul Muttalib, CF230127, and I will continue the presentation from here, which is, as you can see on the slides in front of you, the data presentation. Without any further ado, let's jump right into the first point, which I like to present. For your information, the data collection gathered over a 31-day period, which forms the core foundation for analysing the hydrological behaviour in the Kelantan River catchment area, particularly between Gua Musang and Kuala Krai from 11 November to 11 December 2024. All the data was obtained from the official Public Info Banci website. And as for the rainfall data, I use rainfall data from 3 stations, which is the Gua Musang station, Dabong and also Kuala Krai stations. Several dates recorded high rainfall, especially on the 18 November, 21st November and also 10 of December, which recorded the highest rainfall up to 91 mm at Kuala Krai. And as for the water level data, it was taken from the Kelantan River Station in Kuala Krai. There's a clear pattern showing that after heavy rainfall, the water level increased, for example, reaching 24.19 meters on 11 of December, right after the peak rainfall on 10 of December. This data basically would help us to show the relationship between rainfall and river response, and also highlight spatial rainfall variation between stations, which is quite important for us to understand the flood behavior in those areas. And in summary, this 31-day data from Public Info Banci gives a strong basis for analysing rainfall runoff in the Kelantan River catchment. And next, I'll be showing you these 3 hydrograph and 1 hydrograph that I obtained in the Public Info Banci website. On the top left of the slides is the hydrograph for Gua Musang station. Hydrograph for Kuala Krai station is on the top right, and on the bottom left of the slides would show you the hydrograph for Dabong station. And last but not least is on the bottom right of your slide is hydrograph for Kuala Krai station at Sungai Kelantan. All these graphs were gathered from 11 of November up until the 11th of December 2024. As for the last slide for our data presentation, this actually explains the changes in terrain and river slope across 3 main segments of the Kelantan River Basin from Gua Musang to Kuala Krai, and how these physical features actually influence the river's behavior. From for Gua Musang to Dabong, which is the upstream to midstream, this area is steep and hilly, causing the river to be narrow and fast flowing. As it nears Dabong, the slopes becomes more moderate and the river starts to widen. For Dabong to Kuala Krai, which is the midstream to downstream, the terrain flattens into a flat plain and the river flows slow. Near Kuala Krai, it becomes more meandering and receives tributaries, increasing flood risk due to low gradients. For Kuala Krai onward, which is the early downstream, from here, the river flows through flat land with minimal slope, leading to sediment build-up and floodplain development, especially during the monsoon season. As for the conclusion, as the slope decreases downstream, the flood potentially increases, whereby it's an important factor in understanding river behavior.
So next I'll present about the result and analysis. In result analysis, we calculate the hydrograph, separation method, UH ordinate, and peak flow. So next, for the hydrograph data, we obtain by using the mini equation. So the value that we obtained, I'm done to plotting that hydrograph. So after that, we use the separation method, which is I using the straight line method, to obtain the base flow and direct flow value. So by that, we can calculate the UH ordinate. And before we calculate the UH ordinate, we must to find the direct runoff volume and runoff depth. Total direct runoff volume is total direct flow that we convert to MQ. So we obtain for this graph we obtained 2.45 multiplied to 10 power 10 m3. After that, we calculate the runoff depth is total direct runoff volume over catchment area. Catchment area for this project is 5.96 multiplied to 10 power 8 m squared. So we obtained 4,111 cm, and to calculate the UH ordinate is a direct flow over to runoff depth that we calculate before. So for the next hydrograph, we use the same method, which is mini equation first. After that, we use the separation method, which is the straight line method, and we calculate the total direct flow and calculate the total direct runoff volume, which is we got 5.28 multiplied to 10 power 11 m3. And for the runoff depth, we obtain 88,591 cm, and all of that we obtain the UH coordinate graph that we plot here. For the last hydrograph, we obtain the total direct runoff volume is 6.75 multiplied to 10 power 10 m3, and a runoff depth we obtain the value is 11,325 cm, and we plotting the UH ordinate, and here the UH ordinate. So that's all from me, and I will pass to the next presenter.
So hi, next we will find the peak flow using rational method. So the first step, we need to find the SO, the slope of overlaid surface, and the equation is HF over L multiplied to 100, and the answer we will get for SO is 0.55%. And next, we will need to find time to concentration, TC equals to TO. So equation for TO is 107 multiplied to N multiplied to L the power of 1 over 3 divide to S the power of 1 over 3. So the answer that we will get for TC equals to TO is 208.11 minute or 3.47 hours. So the next step, we need to find the rainfall intensity, I. As you can see here, the equation. So rainfall intensity, we need to find using the table of MSMA second edition. So the answer that we will get for rainfall intensity is 90.47 millimeter per hour. So the last step is we need to find a peak runoff QP, and the equation is QP equals to I multiplied to C multiplied to A and divide to 360, and by using the formula, the answer that we will get is 550,434.56 meter cubic per second. Next is Manning equation. Manning equation is to find discharge of water. So the equation is Q equals to 1 over N multiplied to AR, the power of 2 over 3, multiplied to S, the power of 1 over 2. Q is discharge of water, A is area of cross-section, SO is slope of waterway, and the N is the Manning ruggedness coefficient. So the first step, we need to calculate for every cross-section, upstream, midstream, and downstream. And the data that we get, all is from Google Map Pro. So we using the trapezium. So the perimeter is 847.11 meter and the area 4426.40 meter square. Cross-section for midstream. Perimeter that we get is 716.48 meter and the area is 3018.86 meter square. And the cross section for downstream perimeter we get 628.19 meter and the area is 2100 meter square. So this table is to find average peak flow section for upstream, midstream, and downstream. Slope, we use 0.55 for all section. Manning ruggedness, we use 0.035 for all section. Weighted perimeter is from previous calculation, and sectional area is also from previous calculation of trapezium that we already calculate. And hydraulic mean radius is R equals to A over P. So sectional area divide to weighted perimeter. And finally, we will use the Manning equation. So we will find every cross section Q, and then we will sum up all the section and we'll divide by 3. And the average peak flow that we will get is 182,925.1. Thank you.
For the discussion, first of all, the analysis of rainfall data, rainfall and stream flow data across the Gua Musang and Kuala Krai catchment provides valuable insight into the hydrological behavior of the Kelantan River, especially during the northeast monsoon season. Various information was taken from the study, such as water level data and rainfall data. Based on the 31-day data collection and the hydrograph results, several important patterns and relationships have emerged. The data collected from the catchment border used to determine the peak flow and the flow rate. The peak flow is calculated using the rational method and the Manning equation. Calculation using the rational method shows that the peak flow value was 550,434.56 meter cube per second, while using the Manning equation was 182,925.1 meter cube per second. Furthermore, for the discussion, the hydrograph analysis for the Kelantan River at Kuala Krai shows how the river discharge changes in response to rainfall. During heavy rain events, especially between 26 to 29 November, the hydrograph displayed sharp peaks indicating fast runoff entering the river system. To better understand this flow, the separation method using a straight line approach was applied to divide total flow into base flow and direct runoff. The results showed that direct runoff significantly increased during periods of intense rainfall, proving that the catchment responds quickly to storm events. After separating the flows, the unit hydrograph was created to represent how much stream flow is generated from 1 cm to rainfall.
The UH ordinates showed high values, especially on 10 December, that is 67.639 meter cube per second per centimeter, reflecting the strong impact of rainfall on river discharge.
And as for the conclusion, I can conclude that the study successfully analysed the hydrological behaviour of the Kelantan River between Gomusang and Kuala Krai using real rainfall and water level data that we obtained from Google Earth Pro and Public Info Banjir. It showed how rainfall patterns affects stream flow and flood risk. Some key findings include hydrograph reveal the relationship between rainfall and runoff. We use the rational method and meanings equation to estimate discharge, and we found that a steeper upstream areas cause faster runoff, and while flatter downstream areas have higher flood potential. This study also helped us improve understanding of flood risk and the importance of combining traditional and digital tools in environmental analysis. Overall, these findings support better flood management and planning, especially in flood-prone river catchments in Malaysia. That is all from me. Again, I am Putra Malik Khalid bin Abdul Muttalib. Assalamualaikum. Bye for now.